Okay, let's talk about the derivatives of some trig functions. So let's start by looking at sine x. And what I want you to think about is what would the graph of the derivative look like? So remember that when we're at the tops and the bottoms, the maximums and minimums, the derivative is 0. So if I'm thinking about the graph of the derivative of this function, the tangent line is horizontal at these places at the tops and the bottoms. So the derivative would be 0 at those places. When the graph is increasing, then the derivative is a positive number. So the derivative would be positive. When the graph is decreasing, the derivative is a negative number. So it would be negative, something like this. This part over here might be a little bit taller. Like that. So what you should notice is that the graph of the derivative of this function looks a lot like that function right there. So what we can say is that the derivative of sine of x is cosine x. So let's do a similar thing for what happens when we look at the cosine. So remember, the derivative will be 0 at these tops and bottoms of the function. So the derivative will be 0, at pi, and at 2 pi. And then when the function is increasing, the derivative is positive. When the function is decreasing, like between 0 and pi, the derivative is negative, and then increasing, positive again. So this almost looks like the sine graph because it starts at 0, right? Remember, the sine graph starts at the origin at 0, 0. But instead of going up like the sine graph should, like that, this one goes down. So this is the sine graph reflected. So the derivative of cosine is going to be negative, the reflecting part, sine of x. Okay, we can do similar derivations. We could use some rules to find out what the derivative of tangent and cosecant and all those things are, but you should just try to memorize these. So the derivative of tangent is going to be secant squared of x. The derivative of cosecant is going to be negative cosecant x, cotangent x. The derivative of secant is going to be secant x, tangent x, and the derivative of cotangent is going to be negative cosecant squared of x. Okay, so what I want to do is use all of those derivatives to find some derivatives of functions. So the first question says, find the derivative of f of x equals sine x plus tangent x. And what you know is that when you want to find the derivative of two things added together, you can just add the derivatives. So to find the derivative of sine x plus tangent of x, you're just going to add up the derivative of those two things. So f prime of x is going to be the derivative of sine, cosine x, plus the derivative of tangent, secant squared x. Okay, so now derivative of 3 cotangent x. Remember, when you have a constant in the front, the constant multiple rule says you can just leave the constant there. So 3 times the derivative of cotangent is negative cosecant squared x. We can simplify that a little bit and say negative 3 cosecant squared of x. Okay, another thing we do with derivatives is find the equation of a tangent line. Remember, to find the equation of a line, you need a point and you need a slope. So this one tells us find the equation for the line that is tangent to y equals pi plus 2 tangent x at x equals pi. So that's my x value. X equals pi is the x value that I'm going to use. To find the point, I'm going to take that x value and plug it in. So I'm going to plug in pi for x. So I'm going to get y equals pi plus 2 times tangent of pi. Tangent of pi is 0, so I get pi. So my point is going to be pi, comma pi. To find the slope, I'm going to take the derivative of this function, y plus pi plus 2 tangent x, and then plug in pi, and that will give me the slope. Okay, so the derivative of pi is 0, plus 2 times the derivative of tangent. Remember, if you look back up in your chart up here, the derivative of tangent is secant squared of x. Okay, so to find the slope, I plug in pi for x. So 0 plus 2 secant squared of pi. Okay, so secant squared of pi is, let's see, negative 1. So secant of pi is negative 1. So 2 times negative 1 squared, or 2. Okay, so I have my point, pi comma pi. I have my slope, 2. And now I'm going to write the equation of the line. So y minus pi is 2 times x minus pi. If you simplify that, you should get y equals 2x. So I'm going to distribute this and I get negative 2 pi, add pi, so minus pi. So this is the equation of the tangent line to the function pi plus 2 tangent x at x equals pi.